So we just finished evaluating piecewise functions. Now we want to use that information that we just learned to graph piecewise functions. In order to graph a piecewise defined function, we need to choose several values for each domain, including the endpoints, if there is any, of each domain, whether or not that endpoint is actually included in the domain or not. Label each of these endpoints as included or not, meaning whether the point is closed if it's included or open if it's not included. Then I want you to sketch the graph of the function. So remember our cell phone plan? We had C of t equals $20 as long as you spoke between 0 and 60 minutes, and $20 plus an additional 40 cents for every minute after 60 minutes if we went over our 60 minutes. So what I would like to do is I would like to find several values for each domain, evaluate them, and then graph my function. To keep this a little more simple, I'm going to use the first piece of my graph in green and the second piece of my graph in red, just so you can be very clear about where everything is coming from. For my green values, I look first to the domain, and I'm picking some domains between 0 and 60. And I would definitely like to choose 0 and 60 because those are my endpoints. And I'm going to choose one more in between at 30. I want you to note 0 is included in my domain, so we're going to have a closed circle here. And 60, t is less than or equal to 60, so I'm going to have another closed circle here, or it's included. Let's take a look at my red function. What are my values for t in my red function? Well, I know that t has to be greater than 60, so I'm going to pick things that are greater than 60. For example, 90 and 120, and this just keeps going because there is no end point to that. Although there is a lower bound endpoint, t has to be greater than 60. So are we allowed to include 60 for the red? Well, no, we're not allowed to include it, but I do need to evaluate it at 60 so I know where to put my open circle. Is this still a function, even though I have two values of t for my domain? Well, yes, it's still a function. And the reason it's still a function is because one of the values is going to be closed versus the other value is going to be open. So we still have a function intact because this is only a boundary point for the next set of values higher than it. You have to do both the 60 in the green and the 60 in the red because the 60 is the boundary point, but you have to identify as one as closed and the other one should be open, although it is still a function. Going back to the green function, if I talk for 0 minutes, I'm going to be charged $20. If I talk for 30 minutes, I'll be charged $20. And if I talk for 60 minutes, I'm going to be charged $20. For the red function, if I talk for 60 minutes, even though 60 doesn't really belong in there, if I evaluate it, I find 20 plus 0.4 times 60 minus 60. Well, that's 0, and 20 plus 0 is still getting me just 20. Notice they happen to be the same value, which is fine. What if t is 90? We have 20 plus 0.4 times 90 minus 60. So that's an additional 30 minutes. Or 20 plus 12, which is getting me a $32 fee. And the last one, if I spoke for 120 minutes, $20 plus 24, I'm getting $44 fee. Now this actually was the one that we came up with on the last example when we were evaluating using the same function. Notice that this keeps going, so you'll have an arrow at the end. Now I'd like to plot this function. I know my t's I have to have from 0 all the way till 120. On my c of t direction, I would like to have at least 0 to 44. I'll walk up in increments of 5. For the green piece of my function, I have a point at 0, 20, and that's a closed circle, 30, 20, and 60, 20. And you can see that's the end of my green, and I can connect them with a horizontal line. That's my constant rate. For my red function, I have an open circle at 60, 20. 60 doesn't really belong in this domain, but I need an endpoint. So at 60, 20, I put an open circle here. Now that open red circle is basically filled in by the green circle below it. So it really is still a closed circle. The green circle, which is closed, is more powerful than the open red circle that's laying on top of it. You can still see right through it. It's 90, 32 is right about here. I'm doing my best. And then 120, 44 is right about there. And if I had a better graph paper, it might be a little straighter here. But we have a nice straight line right there. Notice you have a constant rate until 60 minutes, and then after 60 minutes, this plan takes off. I probably would not buy this plan if you plan to talk a lot this month, any more than $60. This might be just like a good emergency phone. So looking at this, I'm going to not choose this as my plan, but maybe someone might use it for just emergency only phone. Let's do some more examples. We have f of x equals x plus 1 if x is less than 0, or x squared if x is greater than or equal to 0. Again, I'm going to break this up into two colors. I think we used red and green. In each of the domains, the domain for the green function and the domain for the red function, I need to pick several values. I need to pick in the green function values that are less than 0. Do I have to include 0? I have to choose him as a choice, but then I have to make a note that he is an open circle. And then I have to pick values that are less than him. I'll go -1, -2, -3. And I'm going to put a dot, dot, dot here because I want you to remember that the values keep going. It's not an endpoint, but it will have an arrow there. On my red function, I want values that are greater than or equal to 0. So I'm going to choose 0, 1, 2, 3. Now, how am I allowed to have two zeros here in my x? Is that still a function? Well, yes, it is still a function because one of the zeros is closed. And the reason it's closed is because of the greater than or equal to symbol. And then the green one is open because it has no or equal to symbol. This is still a function. I want you to really understand that. Now when I go back and plug in my domain, I'm plugging the green values into the first function. I'm going to plug the red x values into the second function. So when I plug -3 in, 1 plus -3 is -2. 1 plus -2 gets me -1. 1 plus -1 is 0. And finally 1 plus 0 is 1, although that's an open circle. On my red function, I'm plugging 0 in to x squared, so 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then I'm going to plot those two functions. So to graph my green piece, I'm going to plot -3, -2, -2, -1, -1, 0, and 0, 1. But when I get to 0, 1, make sure you put a nice large open circle there so I can see right through it. And I can tell that this piece looks like a straight line. On my red function, I have 0, 0, 1, 1, 2, 4, and 3, 9. And when I connect those, I have a nice parabolic function here, although you only see part of the parabola. And this is my piecewise defined function. Is this still a function? Well, yes, even if you pass your vertical line here at 0, you're only really at 1 point at a time. Your green values come up here closer and closer and closer to 1, but then they hop immediately down to 0, and then they continue on. So this is still a function. It still passes the vertical line test. For the next function, we have 3 pieces to our function, so we're going to need 3 different colors. When I pick x values, I'm picking from 3 different domains. My green domain starts from -3. Now that's not an infinity, it's the endpoint is -3, and I need to pick values all the way up until 0. Although 0 is not included, or we'll call it open. The -3, though, because it's less than or equal to it, is closed. For the red function, I have the only domain is at 0, and that is closed because you're allowed to be equal to 0. And thirdly, x is greater than 0, so I'm picking all the values greater than 0, including 0. But I just make a note that that is an open circle because x is greater than 0 but not equal to it. I just need to know where to end my line. On the blue, I'd like to make a note that this does keep going on forever because there is no endpoint above 0. When I go back to my green function, I'm plugging -3 in to the green equation. -3 plus 3 is 0. -2 plus 3 is 1. -1 plus 3 is 2. And 0 plus 3 is 3. For my red function, when I plug in 0, I'm getting out the value 2. And for my blue function, when I plug in the value 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 2, well, the square root of 2 is some decimal, 1.4, but I really is not something I want to graph. Now, I'm the one that picked these values, right? I can just say, you know, I don't really like that value that I picked. I just started picking values greater than 0. But I don't have to use that one if I don't want to. How about the next one? The square root of 3, well, that's still not something that I know in my head, so I'm going to take that out. What is the next perfect square that I do know? I know the perfect square of 4. Square root of 4 is 2. So I have more values here, but I have, I think, enough for me to graph. On my first green piece, I'm going to plot -3, 0. It's a closed circle. -2, 1, -1, 2, and at 0, 3, I want an open circle. I made that nice and big just to make sure you could see that on the video. On the red piece, I have a point at 0, 2. That's a closed circle. And on my blue piece, I have an open circle at 0. Notice that this is still a function. I'm only defined at 0. My value at 0 is 2. Even though I have 2 open circles here, that's okay. I'm not really defined there. It's just an open circle endpoint for my other 2 pieces, my green piece and my blue piece. And I have 1, 1 and 4, 2. And now I have the graph of this piecewise defined f of x. Our last example has 2 pieces. All you do is green again and red again. But notice that my domain is a little bit different than before. X is not equal to 0 and x is equal to 0. So all values that are not equal to 0 are going to lie in my green piece. And the only piece that is going to be in my red is the value at 0. So for my green domain, I'm going to choose -2, -1, 0, 1, and 2. Notice that this keeps going in both directions, but I just need to grab a few. Now some students say, hey, you're not allowed to equal to 0. And you're right, I'm not. So I'm going to make a little note that says I'm open at 0 for my green piece. Whereas for my red piece, the only value I'm allowed to plug in is 0. When I plug in the absolute value of -2, I'm getting 2. The absolute value of -1 is 1. The absolute value of 0 is 0. All the way down. But for my red function, when I plug in 0, the only value I get out is 1. To plot this, I have -2, 2, -1, 1. At 0, 0, make sure that you have an open circle there. I have an open circle in the green part, but I have a closed circle for my red part. 1, 1, 2, 2, and you can see that your line kind of looks like a V shape, which we're going to talk a little bit more about next unit. For my red part, I have 0, 1. I have a nice closed circle right there at 0, 1. Is this still a function? Well, sure, it still passes the vertical line test at every single point, including 0. It's only defined at one point at 0, even though we have an open circle that's not really defined there.